It'll be first part really just telling you about Galvanize and the program and kind of what we're doing, and then some thoughts around how data science is going to continue to transform education. And when I was thinking about this morning and putting my slides together, I said, okay, how is data science evolving technology education? And I said, actually I should have wrote how data science will evolve technology education, because we're not there, and we're not there yet, but we are in a very, very exciting time. But before we get to Galvanize, people always ask me, why do you do what you do? And what I do is I'm the CTO of Galvanize. I run our curriculum and content teams and help kind of shape the future direction of what we teach and how we teach. And before Galvanize, I was the co-founder and CEO of a little company called Zipfian Academy, which is the first data science immersive boot camp in the country. And we joined Galvanize about a year and a half ago and brought the whole team over. And people always ask me, why do you teach, right? Isn't it this whole old adage that those who can't do teach, right? Did you not want to do data science? And I said, no. I love data science. My personal passion is how the two intersect. But in order to have a context of why education is so important, especially going into the next 10 to 20 years, I want to have a little bit of a history lesson. This popped up in my newsfeed today. So NPR has done some great work. They had this article that came out in 2015 in February, and it was tracking the basically most common job in each state between 1978 and 2014. And I spared you guys the animation and just went directly to 2014, but what, based on this image, is the most popular job in America right now? Truck driver, yep. And then this morning, if you guys were watching Hacker News, you saw that this company came out of stealth. It was called Otto. It was a bunch of ex-Google and Facebook and Tesla engineers. And they are building a $30,000 apparatus, that's the thing that you see right there in the front of the semi-truck, that essentially will allow it to do national autonomous driving, right? Putting all of those people out of work. And they went out south. You also see that Volvo and Mercedes also launched their own self-driving cars and self-driving semis. And so we're in this kind of perilous future, right, where our most popular jobs in America will be automated. And I found this as well, also done by NPR. This was also done in 2015. And the title of the article is, "Will Your Job Be Done by a Machine in the Future?" I suggest you guys check this out. Statisticians, it was the closest thing I could find to a data scientist. It's kind of our proxy here, are in good shape. It's about 21.8% of being automated, but those pesky software engineers, not so much, 50% chance. So I think everyone in this room is probably relatively safe if you're self-selected into this conference, but there is going to be a need for people to retool and reskill. And a lot of that is going to be working with artificial intelligence, working with data, being able to program the machines rather than working for them. And so I think making sure that we are providing opportunities and on-ramps for people to retool either at the beginning of their life, midlife, or later in life so that they can take advantage of this new economy is going to be key. And based on my experience, traditional higher education institutions just can't keep up and can't move at the pace of industry. So that's what brings us to Galvanize. That's where you're here. We're not just a pretty event space. We're primarily an education company. And our motto is it's where learning goes to work. And this is really born out of the need for education to be more responsive, to move fast at the pace of industry. And in order to do that, we blend the line between learning and working. And so when you're on this campus today, take note. You'll see that there's over 200, almost 250 students on campus learning web development and data science. There's over 700 members who are coming from big companies like IBM and Google to small 1- and 2-person startups. And they're all working hand in hand in the same environment, and they're learning from each other. They're taking programs and mentoring and completing projects with our mentor companies, and our companies are getting access to the high level of technical education that we provide. And I think this is really the model for what education can be and what it needs to be going forward, is that people are not hiring based on degrees anymore. They hire based on competency. They're based on what you can do, not necessarily what piece of paper you have. And there's no better way to learn skills than on the job itself. And so we always say that we're solving this chicken and the egg problem between you need experience to get a job, but you need a job to get experience. And so for someone coming into, let's say, data science or web development for the first time, we plan on being the bridge. We have a couple campuses nationwide. We're primarily US-based. So you're in our San Francisco campus, which is our largest, but we also have campuses in Colorado, where the company was initially founded. Seattle, we're opening up Phoenix soon. We just opened up Austin, so I'm on a plane quite often. But they're all beautiful and they're all large, and they all follow the same pattern of bringing together industry and education. And we do this primarily through 3 programs. So we have a full stack immersive, a data science immersive. So a full stack is 6 months, our data science is 3 months. And we also have invested pretty heavily in doing data engineering training. So this is part-time workshops in corporate. And we've graduated over 500 students last year, and we're on track to probably triple that this year. So lots of growth. And it's by large worked. 97% of our students from our web development program have found jobs within 6 months. 94 from our data science program, and more often than not, they are doubling their salary in a 3 to 6 month program. These aren't easy programs. You know, when we say it's an immersive boot camp, we mean it. People are saying goodbye to their friends and families for a period of 3 or 6 months, and this is all they do. And I think that person-to-person commitment in that in-person component is something that's really important. It allows a true acceleration of learning because you're working with pairs, you're working with a group, you're not just working on a problem set or going to lecture. In our data science program, which is probably of most interest to you, we cover pretty much all the greatest hits. It's primarily in Python, and it's a 12-week full-time program, but we cover both the machine learning, the big data, and the underlying theory. The bar is relatively high. We look for people who have a background in software engineering, not necessarily as a professional, but they know how to code, and the right math and stats background. So if you've taken linear algebra and statistics in college, you should be good to go. And they work at companies like Tesla, Uber, Facebook, Udacity, Twitter, Asana. We've had a tremendous luck placing data scientists and web developers in some amazing companies, and then they come back and continue to support the program, both through mentoring and guest speaking. We recently just launched a data engineering program as well. And that was built in collaboration with industry, which is part of our big ethos, and that really covers the kind of back end of data science. So how do you process and shuttle around large, petabyte scale amounts of data, and we see that our data scientists and data engineers typically work in concert to help break down that wall between engineering and data science. So, Galvanize sales pitch is over. Let's talk about some more fun stuff. One of the reasons I think that we're successful is we think about our curriculum as a product. And one of the ways that we do that is having a very quick iteration loop in our development process. I was in a conference last week with a bunch of really innovative people from higher education, and we were talking about how do immersive schools and higher education work together. And one of the things that fell out of that is there currently isn't really a bridge between how fast we can move and how fast they, through regulatory requirements, can. The way that we look at our curriculum is we're trying to meld the best parts of what higher ed has done, which are things like adaptive learning, standards and objectives mapping, things like mastery tracking, and thinking about learning experiences, with the speed of a Silicon Valley startup. And so we actually start, and we have a consortium of industry partners that we work on the standards and objectives, right? We help map out what are the skills that are required for a particular job, say it's web developer or data science. And then how do we actually validate those in an automated way? So you can think of it as test-driven development, in that we're writing tests for things that can be quantified, and then actually writing the curriculum and learning experience. It's just similar if you were doing test-driven development, you would write the tests and you make them pass. And then we get feedback from students and industry, and also from the outcomes of our students. And our curriculum is changing daily, if not weekly. We're graduating a data science cohort every 7 weeks, and we're continuously updating and getting feedback, both from how we teach, but also how the industry continues to evolve. Because data science, as it stands today, will not be the same a year from now. A lot of machine learning will still stay the same, but the new technologies, the new ways of thinking, new algorithms. So we have to stay at the pace of industry, and part of that is not expecting that we're going to have all the answers. We need you guys to tell us to make sure that we are producing the best content that's available. And we think about this as a lifelong journey. right? It's not just a one and done, come in here and do a 3-month program and then you're kind of off and you're a full-fledged data scientist. We think of ourselves as an accelerator program and that you are going to be learning throughout your career, and we hope that you come back someday. And so we think about, someone discovers us on the website, maybe they take a course at Udacity or Codecademy. We go in and have an assessment and actually figure out their skills and what they can do. Based on that, they come in and do some pre-work and learning, get placed into an amazing career, and then start the cycle over again from within industry, discovering what they need to know, relearning on the job, getting that industry immersion, and then coming back maybe 5 or 10 years down the line and being able to work with Galvanize to reskill and retool as the industry continues to evolve. So let's talk about data. We measure a lot of things in our programs, from our admissions to our student success, which is really owning the student life cycle within the program, and then career services after they're placed. And there are some opportunities for automation here. Right now, our admissions are all done by hand, and we create what we say a quality score that's made up of both technical interviews, soft skill interviews, and take-home assessments. One school, Holberton School, you probably have not heard of it, they just launched. They have actually completely automated this process, and it was really inspiring when I was talking to them last week. But we don't want to take the human element out of it. I think that's what a lot of online education gets wrong, and that they try to put everything at the mercy of the algorithm. One of the reasons we're successful is because we have that human element, and that we're actually building that relationship with the people. Based on that, they go into student success. So we collect a lot of surveys. We try to do things like measure their problem solving, how fast they complete exercises, where is their engagement, automated assessments, which I talked about earlier, and then getting things like exit tickets on a weekly and monthly basis so that we have a good pulse over how things are changing overall. And largely, we're not just looking for competencies, we're actually looking for deltas. Someone can come in, and if they are learning a ton, we can give them the same assessment week to week, and if we see a big jump there, then they're doing well in the program. And then we measure things on our placement rate, how fast it takes to get people placed, their starting salary, and their net promoter score. But the dream is not just these metrics. I think when we talk about how data science can really be effective in education is how do we actually build this feedback loop? One of the most interesting data sets is a longitudinal record where I can take both their education and work history, how they did on an admissions test, how they did throughout the entire program from automated assessments to what data they fed us, and then what their ultimate outcome was, right? Where did they get placed? How happy are they with their job? And then from that, we can actually build a very interesting model where we can then feed that back into our admissions and student success process and be able to find diamonds in the rough. And one of the hard parts about admissions is that it's primarily a filter, and that you have to have the opportunity and the time and the money in a lot of cases to actually go through a process like this. And by creating a model and being able to suss out things in a much more quick manner and have a higher degree of accuracy, we can actually open this program up to a lot more people, and we can do it at a much cheaper cost, which is our ultimate goal. And then from there, we can do things like predictive analytics on student success. And that's why I kind of mentioned earlier that we're not there yet. We're still collecting the data. And one of the hardest parts about what we do is just the sheer amount of scale. You can think about it, it's a very wide data set with not a ton of students. We've only done about 2,000 already. So we're starting this process now, but as we continue to scale and get better data, and we're launching an online component as well that will help us collect even more data, I think we can actually create some really interesting insights. And one of the ways I've been playing around with doing this, has anyone heard of item response theory? We've got one. All right, so this will be new. I was hoping someone would learn something today. So item response theory is this really interesting branch of mathematics, and it's used, has anyone taken a GMAT or an ACT? Any of those? So if you have, you've actually used item response theory. It is the successor to what's called classical test theory, where you would look at a student and their grades as the kind of accumulation of points within a particular test. And what that doesn't do is it doesn't allow for variability in how hard the question is. And so what item response theory does is essentially it applies a logistics sigmoid, and we're trying to actually estimate the probability or the underlying latent feature, which we call theta here, of how successful or how much mastery does an underlying student have. And we can model this in two directions. One, this allows us to figure out which questions are actually difficult and which ones are not. And we think about that as how much information is contained in that question. If it's easy and everyone gets it, that's not a good qualifier. But if it's way too hard and no one gets it, and someone who has a very low competency just happens to have guessed the right answer, those should be treated differently, right? You want to look at the student as a whole, and being able to model and really throw out the assumption that all questions are the same or they all have the same value, allows you to have a much more personalized experience. And so on the x-axis here, we have theta, which is their basically perceived mastery, -3 being really bad, 3 being great. And then there's essentially a couple parameters that you tune with this model. One has to do with the person, and the other has to do with each individual question, so you get a matrix. And then from there, you're trying to uncover the underlying theta for that person, which is how much they've mastered. And then through that, what's really interesting is what we're starting to see is you can actually do predictive analytics here. So based on what we've seen so far, we can actually recommend which questions or recommend which interventions we need for that student based on this underlying model. So this is something that's very exciting. It also needs a lot of data. So one of the kind of programs that's successfully rolled this out is Khan Academy. They very finally named it Guacamole, which is why the guacamole is there. And so if you guys want to check this out or actually run some simulations with some data on your laptop, just go to GitHub, Khan/guacamole, and they have a pretty much turnkey solution there for you. And so we were good enough to open source that. And then you can actually take this one step further and do something called multiple item response theory. And this is when you're actually creating a surface. So this is over, I think, 30 different latent features. And so we're not only looking at mastery, but we could think about general intelligence, we can think about grit and gumption. All of these components that fall out of a large test suite, we can actually model across the board and create better assessments and create better experiences for our students. So, with that, are we in a world of the robot tutor? I don't know if you guys remember this from the Jetsons. Are we going to see a world where we have essentially AI coming in and teaching us everything we need to know, and is that really the future, and can we get rid of humans after all? And in some ways we're already doing this. I don't know if anyone saw the story that came out a few days ago. It was called Jill Watson. A professor essentially put IBM Watson as a virtual TA in his artificial intelligence class, and he didn't tell anybody. He named it Jill Watson, threw IBM Watson in there, and they trained it using real-life TAs until it had 97% accuracy or confidence in that it was actually answering the questions. You see, should we be aiming for 1,000 or 2,000 words? I know it's variable, but that's a big difference. Jill steps in, there is no word limit, but we'll be able to grade both on depth and succinctness, blah, 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 blah. And then they ask a more elaborate question, and then Lalith, an actual human TA, jumps in because Watson was not comfortable answering that question. And some people start to wonder if Jill is a computer. If there's anything this has taught me, I should always question if someone I've met online is an AI or not. And before they actually announced that it was an AI, Jill was nominated for the best TA of that year because of how fast and complete and succinct her answers were, because she would get back to people at all hours of the day and night and provide amazing resources. And it was only until she could not answer something did a human have to step in. So are we there? No. But are we getting there? Yes. And this is really exciting to see. But I think what this underlies is the need that AI is not a solution unto itself. What we need to be thinking about, and you see this thrown around a lot, is human-assisted AI. And how do we leverage these amazing technologies and algorithms that we're doing to create better lenses in which to view the world so that humans can actually get involved and take some of the labor out of the equation. Taking a bit of a right turn, I think the other aspect to this is not just the in-classroom experience, but it's also understanding the market and where the trends are going. And I think brightcom did an amazing job of this. They were acquired by LinkedIn, I think, last year. And their goal was to understand and be able to quantify someone's ability to actually do a job. And they did this primarily through a collection of outside data and data science, looking at their resume and doing some natural language processing, and ultimately came out with a Bright score. And they could say, for each individual, what is the probability or what is their score that they're actually going to be able to get placed in this job and be successful. And when we look at the future of kind of what education might be, I think LinkedIn is definitely onto something. LinkedIn has acquired both Bright and Lynda, and if you take a moment to think about it, it's actually a pretty brilliant masterstroke if they can pull it off. LinkedIn kind of owns the world's economic graph, right? They understand where people move and what their skills and competencies. You've given them all of that data. Bright can understand and kind of quantify at a particular level and match people within a particular job. And then Lynda is an online training institution that has a lot of technical aspects to it as well. And so you can think, if LinkedIn's job is to create economic opportunity, wouldn't it be great to be able to take anyone on the planet who's in LinkedIn's network, be able to analyze their skills, and then provide them with a Lynda course and say, these are the 5 courses that you need to take to get to X job. I think it's really interesting if they can pull it off. People I talk to at LinkedIn are being a little closed-mouthed about it, but I think under the surface, that's secretly what they're doing. And we're trying to do something similar. We're obviously not going to go head-to-head with LinkedIn, but we are building our own skills matching service. It's much more tailored to what we do, which is data science and web development. And we're calling it Flight. It's in beta right now. If you guys go to students.galvanize, you can sign up. But right now, it's a manual process, right, where companies can come in, they can provide the skills and the jobs that they're looking for. We can get a curated list of Galvanize graduates, and then our outcome staff actually matches them manually. But really, this is just building a training set for us. Over time, this is easily automatable through the algorithms we don't know, but we just haven't had enough data to go through. And so I think in each aspect, we're trying to create like I said, human-centered or human-assisted AI, where we can leverage technology to create better scalability in the business, but ultimately we're enabling humans to do their job much more effectively and ultimately change more lives. And then when we think about the next steps after item response theory and having good assessments, it's really about adaptive learning. This has been used to a pretty good degree in some K through 12 schools, with companies like Newton being able to actually do a fair amount of adaptive learning, but we haven't really seen it in adult education. We haven't really seen it in technical education, where we're taking content, we're actually collecting data, we're building predictive models that enable both students to understand where they are in the course, and for the instructors to really see at an individual level how they can actually come in and do an intervention and talk to that person, potentially get them more courseware or some sort of remedial training. And then have that go in a full adaptive engine where essentially it follows the same theme of human-assisted AI. How can we use and collect data in order to improve the student experience? You even get to things like out of this lecture model and into a fully baked personalized plan where students can grab an iPad or grab a piece of paper and they know exactly where they need to go all day, but it's based on the needs for them and what competencies they need to master, rather than a factory model, which is kind of where we are now, where everyone sits through the same lecture, everyone sits through the same exercise. It works, but it can always be better. So I'm almost out of time, and I'm going to leave some for Q&A. So like I said, Galvanize provides access to talent, expertise, and an ecosystem. So we're always looking for potential hiring partners. So if you're hiring data scientists or developers, I would love to talk to you. We do a lot of corporate training as well. We're obviously hiring because we've got a lot of work to do for both data scientists and software engineers. We've got amazing event space, as you guys already well know, and we're home to many, many startups and established companies. So if you want to get involved in kind of our vision of the future of education, if you want to mentor or work on a capstone with a student, we're always looking for data. But like I said, we're industry aligned and we can't do this without you guys. So you're the stuff that makes it work. Thank you.
Thank you very much, Ryan. Thank you.